Hello students, how are you all? Welcome back to Akshar IT Foundation classes. I am your chemistry faculty S. Mohan. Students, in the last class we started the very important chapter, that is organic chemistry, right? In that we discussed so many things like what is organic chemistry and what was its old definition and what was its new definition and why carbon compounds are more than 5 million. This all we discussed, right? So today we are going to continue with the same topic, and today's our topic is about the formation of chemical bonds, okay, by the carbon. So here, before going to that, we discussed about the tetravalency, right students? What is tetravalency? Already we discussed this also. Tetra stands for 4, valency, the number of electrons present in the valence shell, right? What is the electronic configuration of carbon? So students, here carbon atomic number is a 6, right? Electronic configuration we write 1s2, 2s2, 2p2. This is the electronic configuration of copper, right? Now for example, if we write it in a box method, so then what we can write, this is 1s, so here 2 electrons are there, 1, 2. This is 2s. And here also 2 electrons, 1, 2. And here it is 2p. Okay, you know that p has 3 degenerate orbitals called as a 2px, 2py, 2pz, right? So 3 are degenerate orbitals are there. But sorry, here this is a 2. 1s2, 2s2, 2p2. Okay, 6 no? 2 plus 2 plus 2. Right. So here 2 electrons are there, 1 and 2. So here in the outermost shell, how many electrons are there? 4 electrons are there, right? So here 2, here 2, so total 4 electrons are there. So the carbon is a tetravalent. Clear? Now students, here already we discussed about the octet configuration. Oct means what? 8. What is octet configuration? The elements which are having 8 electrons in their valence shell or outermost shell, they are stable, right? And other elements which have less than 8 electrons, they are unstable. So to attain the stability, they combine with each other. Is this clear? So in during this, it can form so many compounds. Clear? So that is octet configuration. So octet means what? 8 electrons. Okay. So here if you see, the carbon is 6. Okay. What is its nearest inert gas or noble gas? So here you can see students, here the nearest noble gas is here this is a carbon. Okay. And after the carbon, what will be there? Nitrogen, oxygen, fluorine, neon. Right? And what is the left side? What are there? Boron, beryllium, lithium, okay, and then helium. Okay, I'll write here only helium, right? Helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So in this, you know that here these two, helium and neon, are the inert gases, and they are stable elements. Okay, they are stable elements. So here carbon, to attain the electronic configuration of inert gas, that is helium. Helium atomic number is 2, lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, and it is 10. So here, to attain the inert gas configuration of helium, the carbon has to lose 4 electrons. How many electrons? 4 electrons. Why? Because it has 6 electrons and helium has only 2 electrons. Means what? It has to lose 2 electrons. So to lose 2 electrons means what? Carbon has to lose 4 electrons. Okay. So to form C plus 4. Right. So this is one option. And other option is what? Here you see now. Okay. Here you see now. Here, next inert gas is what? Neon. So to attain the neon's inert gas configuration, the atomic number is 6, but neon is 10. so it requires more 4 electrons, more 4 electrons. So here carbon has to gain 4 electrons. When 4 gains 4 electrons, it becomes a C minus 4, right? So to attain the stability, carbon either has to lose 4 electrons or gaining 4 electrons. Is it possible? No. Under normal conditions, it's not possible. Okay. Why it is not possible? Because carbon, if it gains 4 electrons, so it consists of protons, how many in the nucleus? Only 6. But number of electrons becomes how many? 10. So this 6 protons cannot hold this 10 electrons. So it is very difficult task. Similarly, carbon cannot lose the 4 electrons because ionization energy already discussed. So the amount of energy required to remove an electron is called ionization energy. 1 electron, okay, 2 electrons, fine, but 3 and 4, it's to remove the 4 electrons from the carbon, it's a large amount of energy is required, so which is not possible under normal conditions. Is this clear to you? So that's what here carbon cannot lose 4 electrons or carbon cannot gain 4 electrons. Okay, then how it can attain the inert gas configuration or octet rule? So for here the carbon attains the octet rule or inert gas configuration by sharing of electrons. What it is? By sharing of electrons. So sharing of electrons is called covalent bond. Already I think we have discussed about the chemical bonds. So here ionic bond, covalent bond, already we discussed. So once again, see, ionic bond means what? The bond formed by the complete transfer of one or more electrons from one atom to another atom. That is called as a ionic bond, or the bond formed by between the two different or two oppositely charged ions is called the ionic bond, right? So now we are discussing about the covalent bond. So very important topic, students, here. Covalent bond. Covalent bond. The covalent bond is what? The bond formed by the sharing of electrons. The bond formed by the sharing of electrons. The bond formed by the sharing of electrons is called the covalent bond. Okay. So how the electrons will be shared? So here, students, here, for example, there is one atom. Let's imagine there is one atom called A. Okay. A can provide 1 electron. And then there is another atom called B. For example, imagine that B also has 1 electron. So A is providing 1 electron, B is providing 1 electron. And both the electrons are shared by both the A and B. So here the sharing of electrons takes place. When the sharing of electrons takes place here, one bond is formed between them. This bond is called a covalent bond. What is called? A covalent bond. So the covalent bond is formed by the sharing of electrons. Okay. So here carbon undergoes covalent bond. Okay. And by using this covalent bond, it can form millions of compounds. Right. So today we are going to discuss about some carbon compounds, how they undergo the covalent bond. Okay. So students, here in the covalent bond we are going to discuss here in the shape and structure, okay, of the carbon compounds, or neatly explained by the process called hybridization. Which process? Hybridization. Okay. Hybridization. Okay. So by using this hybridization, we are going to discuss about the formation of covalent bonds in the carbon compounds. Clear? So before going to the hybridization, first I would like to explain you what is sigma and pi bonds also. Okay. So students, here first we discuss about the sigma and pi bonds. Okay. Then I will go to the sigma bond and pi bond. So about two bonds we discuss here first. What is sigma bond? The bond formed by the end-on-end overlap. The bond formed by the end-on-end overlap is called sigma bond. Okay, the bond formed by the end-on-end overlap is called a sigma bond. Okay, and sigma bond is denoted by the Greek letter sigma. Is denoted by what? Greek letter sigma. This is the symbol we use. And sigma bond is stronger. Okay, is stronger than the pi bond. Is stronger than the pi bond, and it is independent. Okay, independent means what? Here to form a sigma bond, there need not to be any pi bond. But where is the pi bond, students? Here, the bond formed by the side-on overlap. What is called a side-on overlap is called a pi bond, and pi bond is denoted by the Greek letter pi, and pi bond is weaker than the sigma bond, and it depends, okay, on the sigma bond. Means sigma bond cannot form independently. Sorry, pi bond cannot form independently. First, sigma bond can form independently, and after the formation of sigma bond, then only the pi bond will be formed. Okay. So now, what is this end-on-end overlap and what is side-on-side overlap? Okay. So students, here you know that there are, okay, for example, p orbital is there, you think, okay, p orbital. So p orbital shape is what? Dumbbell, right? So for example, this is one p orbital which is dumbbell shape, okay, and this p orbital of one atom overlaps with the p orbital of another atom like this. Okay, so when this both get overlap, then what happens here? This is the like this. This both get overlap. So here end part of one orbital overlapping with the end part of another orbital. So then the bond is formed between them. This bond is called a sigma bond. This bond is called what? A sigma bond. Sometimes the s orbital shape is what? A spherical, and this is combining with one okay, p orbital. Then also we can get the sigma bond, end on end. Okay, so this is a sigma bond. Or one s orbital when overlap another s orbital, then also the end on end overlap takes place. Then here also sigma bond will form. So this is p orbital. This is S and P, this is S and S. So S is a sigma bond, this is called SS sigma bond, this is called SP sigma bond, and this is PP sigma bond. Okay, so these are examples for the formation of a sigma bond. Okay, so sigma bond is formed by how? End on end overlap. Then what is pi bond? So pi bond means, for example, we have one p orbital, this is one p orbital. This p orbital is combining with another p orbital. So see here. Now here what happens? The side parts. Okay, the side part of two p orbitals, if they combine like this, now what the bond is formed? This is called pi bond. Is this clear? This is called pi bond. Now the question rises that in the previous slide we discussed like p and p is forming the pp sigma, s and p is forming the SP sigma, and SS is forming the SS sigma bond. Now, here in the next slide, what we have seen, the PP is forming the PP pi bond. Now, can S and P bond can form a pi bond? No. And S and S can form a pi bond? No. So, here S orbital can form only sigma bonds. This is very important point. Okay. So, wherever the S orbital is involved in the bond formation, that forms only sigma bond. Okay, wherever the pp overlaps, okay, p orbitals are participating, there may be sigma may be there and pi also may be there. Okay, but s orbital cannot form the pi bond. Is this clear to you? Sure. Now students, here today I am going to discuss about some carbon compounds. So here we have some carbon compounds in a material. What they are discussed is, one is called methane. First one is what? Methane. Second one is ethane, ethylene, acetylene, and benzene. Okay. So let us see methane. Methane. Okay, how methane is formed? Methane formula is CH4. Students, very important. You have to remember how the name methane will be given to this compound, that we will discuss in the nomenclature topic. Now, as of now, let us see here how methane is formed. Is this clear to you? So see how methane is formed. So methane formula is what? CH4 is the methane. Clear? Now, how the methane is formed? See students, here one carbon, 4 hydrogens are there. Carbon is 1, but hydrogens are 4. So carbon is called a central atom. What is called a central atom? So you know that carbon atomic number is 6. Electronic configuration 1s2, 2s2, 2p2. Right? In the box method, what I said, this is 1s, 2 electrons. This is 2s, 2 electrons. This is 2p, okay, 2 electrons are there, right? So this electronic configuration is called ground state electronic configuration. What is called a ground state electronic configuration. So now here what happens in the excited state? In the excited state, the one electron from this, okay, s orbital, it will shift to the this empty p orbital. It will shift to where? Empty p orbital. So then what happens here? Okay, then what happens here? The electronic configuration becomes like this now. Okay, so 2 electrons, and here only 1 because 1 is gone here. Okay, so like this. Now here, this is outermost shell. We want only outermost shell only. So this is 2s and this is 2p. So how many s orbitals are there? 1 s orbital is there, right? And how many p orbitals are there? 1, 2, 3. Okay, 1, 2, 3. So now this 1 s orbital and 3 p orbitals. So total these 4 orbitals will intermix with each other. What happens? Intermix with each other and forms 4 new type of orbitals, so which are called hybrid orbitals, and this process is called hybridization. What is called hybridization? So hybridization means what? The intermixing of atomic orbitals. The intermixing of atomic orbitals. Okay, to form the same number of new set of orbitals called hybrid orbitals. Clear? So now here this 4, that is 1 s orbital and 3 p orbitals, 1, 2, 3. So 1 s orbital, okay, spherical, and 3 p orbitals like dumbbells. Okay, and these 4 are combining and it's undergoing the sp3 hybridization. Which hybridization? sp3 hybridization. Clear? And during sp3 hybridization, these 4 orbitals are combining, so intermixing with each other. So now new set of 4 hybrid orbitals will form. So how they form? They form like this: 1, 2, 3, 4. Okay, so like this 4 hybrid orbitals will form. Clear? So see here now, this is very important. That structure I am going to use in the next topic. So carbon atomic number 6, electronic on 1s2, 2s2, 2p2, s orbital has 2 electrons, p orbital has 2 electrons, but this is called ground state in the excited state. 1 electron from s orbital is going to the p orbital, so this is called excited state. In the excited state has 4, okay, unpaired electrons are there, 1 in s, 3 in p. So 1 s and 3 p orbitals intermix with each other, and this is called sp3 hybridization, because 1 s orbital, 3 p orbitals are undergoing, okay, intermixing. That's called sp3 hybridization. So this sp3 hybridization, when they undergo, they form new set of 4 hybrid orbitals. That is this one. Okay, this is a new set of hybrid orbitals. Clear? Now this I am going to draw in the next page now. Okay, so now see students, here I am going to draw that one. So here 1, 2, 3, 4. Okay, like this 4 hybrid orbitals are formed. Okay, and this is called sp3 hybridization. Students, remember that this is called sp3 hybridization. Okay, now in the methane formula is what? CH4. So carbon is done. Okay, so carbon has 4 unpaired electrons. So what we do now? Carbon has 4 unpaired electrons. Now represent 4 unpaired electrons. So here 1 electron, here 1 electron, here 1 electron, here 1 electron. So 4 unpaired electrons are there, right? Now this is combining with 4 hydrogens, right? It's combining with how many hydrogens? 4 hydrogens, right? So now you know that hydrogen atomic number is 1. What is the atomic number of hydrogen? 1. So hydrogen atomic number is 1. Electronic configuration 1s1. Means what? In this 1s orbital, only 1 electron is there. How many electrons are there? Only 1 electron is there, right? The meaning is what? Every hydrogen has 1 electron in its s orbital. S orbital shape is what? Spherical. S orbital shape is what? Spherical. So now in the methane, 1 carbon is combining with how many hydrogens? 4 hydrogens. Okay. So 4 hydrogens. Okay. So here you see now 4 hydrogens, right? So now see here, this is 1 hydrogen. So 4 hydrogens are combining with this 4 okay, hybrid orbitals of carbon. So this is hydrogen, this is hydrogen, this is hydrogen, this is hydrogen. Okay. So hydrogen has 1 electron. So this is 1 electron. So this is 1 electron. This is 1 electron. This is 1 electron. So now see here, this hydrogen is providing 1 electron, which is in yellow color, and the carbon is providing 1, okay, green color. So 1 electron. So carbon is providing 1 electron, hydrogen is providing 1 electron. Carbon is providing 1 electron, hydrogen is providing. Like this, carbon provides 4 electrons. 4 hydrogens are providing 1 electrons. Now they are sharing these 2 electrons. Clear to you? So these both are sharing 2 electrons. So this is S, this is p orbital, s orbital, p orbital, s orbital, p orbital, s orbital, p orbital. So s orbital and p orbital can form only, s orbital can form what? Only sigma bond. So then what happens here? This is the sigma bond is formed here. Okay. Which bond is formed here? Sigma bond. Here also one sigma bond. Here also one sigma bond. Here also one sigma bond. That's all. This is the formation of a methane molecule. So how can we write in simple shortcut methane? So write carbon, okay, 4 side, 4 hydrogens, 1, 2, 3, 4, electronic dot structure. This electronic dot structure I'm explaining, okay. And carbon has 4 unpaired electrons. So put here 1, 2, 3, 4. Each hydrogen has 1 electron. So 1, 1, 1, 1 electron. Okay. Now this hydrogen is providing 1 electron, okay, to the carbon, and carbon is also providing 1 electron to each hydrogen. So now this all electrons it is sharing. Okay. So in simple way we can write the structure of methane is CH4 like this. That is about the formation of methane. Is this clear to you? Okay. So in the methane, carbon undergoing the sp3 hybridization. Remember students, this is undergoing sp3 hybridization. And generally in the methane, when it's undergoing sp3 hybridization, the structure if they ask you, the shape or the structure if they ask you, the shape is called tetrahedron. Okay. Tetrahedron shape. And the bond angle generally which is there, which is bond angle, that's called bond angle. The bond angle is 109 degrees 28 minutes. 109 degrees 28 minutes. This is a bond angle. And bond length. Okay. The bond length, even is a single bond. So this is a single bond. The bond length in the single bond is 1.54 angstrom. This is bond length. Okay. These points are very important. You need to remember this one. Okay. So this is methane. Clear to you, methane? That's about the formation of methane. Okay. So chalo now. Now after methane, then we go to the next one is what? Ethane is also given. Okay. Ethane. So if you understood methane, then ethane is very simple. So ethane formula is C2H6. What is the formula of ethane? C2H6. So here how many carbon atoms are there? 2 carbon atoms, right? So every carbon undergoes sp3 hybridization. Okay, I said you know that undergoes sp3 hybridization. So it forms how many hybrid orbitals? 4 hybrid orbitals, right? So structure you see now. Here I am explaining the structure. 1, 2, 3, 4. Okay, with 4 electrons. This is a carbon structure already we discussed, right? Like this, how many carbons are there? 2 carbons are there. So now what happens? This is 1 carbon. This is 1 carbon. Okay. Other carbon also undergoes sp3 hybridization. So it forms like this. 1, 2, 3, 4. Okay. So like this, it forms 4 hybrid orbitals, and this also has 4 electrons. So 1, 2, 3, 4. Right? Now here how many hydrogens are there? 6 hydrogens are there, right? Each hydrogen atomic number is 1. It has 1 electron in s orbital. So this is hydrogen combines here. One, two, three, 4, 5, 6. Okay, every hydrogen has one electron. Over, that's all. Okay, now here the sigma bond is forming. So these both are sharing one electron. So sigma bond, here also sharing, here also, here also, here also, here also, here also. Okay, so this is the bond formation. How can you write in simple way? Simple way you can write like this. Okay, electron dot structure, how can you write? Here I'll write. So carbon, 2 carbons are there. Each has 4 electrons. 1, 2, 3, 4. This also 4. 1, 2, 3, 4. Now it's combining 6 hydrogens. 1, 2, 3, 4, 5, 6 hydrogens. Every hydrogen has one electron. One electron. Okay, so they can sharing like this. Like this. Okay, so now simply how can you write carbon, carbon, like this. Okay, so this is about the structure of ethane, and here how many sigma bonds are there in the ethane here? This is 1, 2, 3, 4, 5, 6, between 2 carbons, 1, 7. So if they ask you how many sigma bonds are there in the ethane, there are 7 sigma bonds in the ethane. How many sigma bonds are there in the methane? 1, 2, 3, 4. Only 4 bonds. 1, 2, 3, 4 sigma bonds are there. Clear? So this is the formation of ethane. Clear? Any doubt? Ethane formula is C2H4. So carbon has 4 electrons. So here carbon has 1, 2, 3, 4. Another carbon also 1, 2, 3, 4. And this combining with the 6 hydrogens. Like this, the bond is formed between them. Clear to you? Okay. Now then come to we have the next one is ethylene. Ethylene. Okay. Ethylene also we can say ethylene. And this other name is called ethene also. It's called ethene. And the formula is C2H4. What's the formula? C2H4. So students here, remember here, ethane formula is what? C2H6. And here this is ethene. So the formula is C2H4. Okay, but here what happens the C2H4, a carbon undergoes sp2 hybridization. Which hybridization it undergoes? sp2 hybridization. sp2 hybridization means what? Now see, once again we go back. Okay, sp2 hybridization. So here how many electrons are there? See here, the same structure I am going to draw there. 1, 2, 3, 4. 4 unpaired electrons are there. 1 in 2s, 3 in 2p, correct? And here what's happening? 1 s orbital, 3 orbitals, all are intermixing. 4 are there, 4 are intermixing with each other. But in sp2 hybridization, what happens? In sp2 hybridization, what happens? So here you see the carbon has, okay, so this is 2s and this is 2p in excited state, okay, this is 2p in excited state, and what you seen here, 1 electron, here 3 electrons, like, so this is 1s orbital and 3p orbitals. So there in the ethane and methane what's happening? There is 1s and 3p's, all are intermixing with each other and forming 4 hybrid orbitals, right? But here what happens? Here not all 4 but only 3 undergoes the hybridization, only these 3. 1s orbital and these 2p orbitals only, by leaving that one electron free. Okay, by leaving that electron free, by leaving that, and only these 3, okay, orbitals only undergoing the hybridization. So 1s orbital and 3. So 1, 2, 3. Total how many orbitals undergoing? 3. So now how many hybrid orbitals will form after the hybridization? 3 only it will form, because they are undergoing 3 only. So they are intermixing 3 only. So we'll get 3 hybrid orbitals. Okay. So 3 hybrid orbitals will form. How it will be? It will be like this. 1, 2, 3. Okay. So these are the 3 hybrid orbitals. Now see here, yes, 2 carbons are there. Now I'll draw the 2 carbon structures. Okay, so like this 2 carbons are there, and they are undergoing which hybridization? In ethene sp2 hybridization. So 3 hybrid orbitals only will form. See now, 3 hybrid orbitals. How? 1, okay. So here 3 hybrid orbitals only will form. 1, 2, 3. 3 hybrid orbitals are forming. Okay. So this is one carbon with the 3 electrons. 1, 2, 3. So with the 3 electrons. 1, 2, 3. Right. This is one carbon. This is one carbon. Okay. Now this is one carbon. Okay. Now this undergoes other carbon. No. Other carbons also there. No. That also 2 carbons. That also undergoes sp2 hybridization only. This also forms the 3 hybrid orbitals like this. Okay, so like this 3 hybrid orbitals will form here. Okay, this also forming 3 hybrid orbitals with the 3 electrons. So 1, 2, 3 electrons. Correct? So 3. Now how many hydrogens are there? 4 hydrogens are there. Okay, 4 hydrogens, each hydrogen has one electron in the s orbital. So now that 4 hydrogens will combine like this. 1, 2, 3, 4. Hydrogen, 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 hydrogen. Okay, each hydrogen has one electron. So 1, 1, 1, 1. So now what's happening? So they are forming the sigma bond. Sigma bonds are formed. So in the ethene, how many sigma bonds are there? 1, 2, 3, 4, 5 sigma bonds are there. How many sigma bonds are there? 5 sigma bonds are there. Now, so out of in the carbon, how many electrons are there? Actually 4, but in that only 3 are participating. 1, 2, 3, 1, 2, 3, 1, 2, 3. But whatever this fourth electron is left. Okay, so that fourth electron is present in which orbital? Pz. So p shape is what? Dumbbell. So now what we do? This is not undergoing the hybridization. So this, but p orbital is there. Here also not undergoing the hybridization. There is fourth electron is there. So fourth electron is there. So this 2 p orbitals now they overlap by side on side, sidewise overlap. Okay, they can overlap like this. So now when they overlap like this side on, so this bond, what is the bond formed here? That is called a pi bond. What is called a pi bond? Okay, already explained, you know. So this is pi bond. See, side parallel to each other. If they are parallel to each other, they are combining with then which type of bond is formed here? Pi bond is formed. So there one pi bond is forming. This is a, so their yellow color one is a pi bond. Now how can I draw the structure of ethene? 2 carbons. So see here 2 carbon. This is one carbon. This is one carbon. Carbon, carbon. Now this combining with here 2 hydrogen. This carbon is combining with 2 hydrogen. So 1, 2 hydrogens. And this can also combining with 2 hydrogens. So 1, 2 hydrogens. Right? Now see here, between 2 carbons, this is yellow, red color one is what? Sigma bond. So there is one sigma bond. Right? And what is this one? This one more bond is forming. Okay? This bond is called a pi bond. So this is pi bond. Clear to you? So this is the structure of ethene or ethylene. Now in this ethene or ethylene, the total number of bonds are 6. 1, 2, 3, 4, 5, 6. But in that 6 bonds, okay, this is a second bond. Second bond will be always a pi bond. Second bond within these 2 bonds, the second bond is a pi bond, and the first one is sigma. So total number of sigma bonds, how many? 1, 2, 3, 4, 5. So there are 5 sigma bonds and 1 pi bond. So total number of bonds are 6 bonds will be there. Clear? So that's about the formation of ethene. Now in the ethene, it's undergoing which hybridization? sp2 hybridization. Okay. So this is undergoing what? sp2 hybridization. Clear? So that's about the sp2 hybridization. And here you see, students, here the bond angle whatever is there, the bond angle. Okay, this bond angle is there. The bond angle is 120 degrees. What the bond angle here you can see. This bond angle is 120 degrees. There in the sp3 hybridization, the bond angle is how much? 109 degrees, 28 minutes we discussed, right? So here the bond angle is 120 degrees. Okay, so that is about the ethylene. Okay, so that's about ethylene or ethane. Now then come to the acetylene. Acetylene also we see acetylene, and acetylene is also called as ethyne. What is called it? Ethyne. Formula is C2H2. Formula is C2H2. But in the ethylene or acetylene, carbon undergoes only sp hybridization. Student, remember this one. Sp hybridization. How it is sp hybridization? See now. Just now we discussed now. So 2s. Okay. In that only one electron was there in the excited state, and here this is 2p. So 1, 2, 3. This is 2p, right? So total how many electrons are there? One total 4 are there, but 1 in S and 3 in P. But here what happens? Only one S and one P only undergo the hybridization by leaving 2. Okay, only these can undergo. One S and one P only will undergo to form sp hybridization. So to undergo sp hybridization, only 2 hybrid orbitals will form. Only 2 hybrid orbitals will form, which are linear. What shape this is called? Linear means what? Straight. Linear shape is formed. Okay. So see now, how many carbons are there? 2 carbons are there. 2 carbons are undergoing which hybridization? sp hybridization. sp hybridization means what? How many hybrid orbitals will form? Only 2. How they are? Linear. So see now. So 2 carbons. 1, 2. Okay, so linear, they are combining, and here they are forming which bond here? Sigma bond is formed here. End to end overlap. Okay, now this is combining with how many hydrogens? 2 hydrogens, right? So this is with 1 hydrogen, that is with 1 hydrogen. So this is with 1 hydrogen, this is with 1 hydrogen. Okay, so hydrogen, hydrogen. Okay, here also this end on end overlap, so here also the sigma bond is formed. Sigma bond is formed, right? Now, so it's undergoing sp hybridization, so these 2 are done now. Now, but you see here these 2 are left, yes. Now, these 2 overlap by the sideways. How they overlap? Sideways. 1, I will take other color, green color I will take. 2, here also 1 and 2. I will draw like this, okay. Now see here, now this yellow color one, yellow color one, how these both are parallel. So how they overlap? They overlap by the sideways like this. So this forms one pi bond, okay. And now see the green color one. So here this is green and green, how they are parallel. So now how they overlap? They also overlap by the sideways, okay. So which bond is formed? Pi bond, okay. So this is the structure of ethyne. How can you write it simply? So see now, simple, how can you write it? 2 carbons. This is 1 carbon, this is 1 carbon. So see, 2 carbons. And this is 1 hydrogen, that is 1 hydrogen. Okay, 1 hydrogen, 1 hydrogen. Okay. Now here between these 2 carbons there is 1 sigma bond. Okay, sigma bond. And between 2 yellow colors here. Okay. So 1 pi bond is a pi bond. And between 2 green colors, 1 more pi bond is a pi bond. That's all. So this is the structure of ethyne or acetylene. So total number of bonds how many? 1, 2, 3, 4, 5. Total number of bonds are 5. But how many sigma bonds are there? Okay. So sigma bonds is 1, 2. Out of 3 only 1 will be the sigma bond. Okay. Only 1 will be the sigma bond. So there are 3 sigma bonds. How many sigma bonds are there? 3 sigma bonds and 2 pi bonds are there. Okay. So 2 pi bonds. So total number of bonds? 5 bonds. Clear? So that is about the formation of a ethyne molecule. Electron dot structure. How can you draw the electron dot structure? Very simple. Electrons see 1 carbon, carbon. This another carbon, another carbon. Carbon valence is how much? 4. So what we do? Here put 1 electron, 2, 3, 4 like this. Other carbon is also 4. Put 1 electron, 1, 2, 3 dots. And this is 1 hydrogen, so hydrogen, 1 electron. Here this is 1 hydrogen, so hydrogen, 1 electron. Now the bond is formed between these 2, the bond is formed between these 2, the bond is between these 2. So here 1 bond, here 3 bonds, here 1 bond. Okay, so 1 bond, 3 bonds. So this is the formation of ethylene. Sorry, acetylene or ethyne. Clear, students? So that's about the formation of acetylene structure. Okay, and now the acetylene structure. Okay, shape is what? Shape is linear. Shape is linear, and bond angle 180 degrees, because it's linear. So the bond angle is 180 degrees. Clear to you? Okay. Now, one more is also discussed in our this one, that is called the orbital model of benzene. So, students, we have one more important organic compound here, that is called benzene, and benzene formula is C6H6. Benzene formula is what? C6H6. The structure of benzene will be like this. Okay, 1, 2, 3, 4, 5, 6 carbons and 6 hydrogens. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, and now the bonds will form like this. But you see, if you draw like this, the carbon has only 3 bonds. 1, 2, 3, 1, 2, 3, 1, 2, 3. But carbon valence is 4. It should form 4 bonds. So that's what we put the alternative double bonds like this. Okay, so this is the structure of a benzene. Clear to you? So this is the structure of benzene. Okay, so here one important point what we need to learn, remember, is that when the single bond is formed, single bond is formed, the bond length is bond length. Okay, bond length is 1.54 angstroms. How much it is? 1.54 angstroms. When there is a double bond, generally double bond is there, then that is bond length is 1.34 angstroms. And when it's a triple bond, okay, triple bond means 3 bonds are there, then the bond length is equal to 1.2 angstroms. Okay, this you have to remember. That is very, very important. Okay, students. So that's all. So with this, we completed the first synopsis. Okay, so the first synopsis, what we discussed all, we discussed here complete about the hybridization. So we discussed 3 types of hybridizations called sp hybridization, sp2 hybridization, sp3 hybridization, and formation of methane, ethane, ethylene means ethene, and acetylene means ethyne, and benzene structures. Okay, chalo. Now open your page number 10. Page number 10 in your material. We have some questions. So see that concept based questions. Organic compounds can formed by plants only, animals only, plants and animals, and also can be synthesized in laboratory. What is the right answer? Right, fourth option. So organic compounds can be synthesized, derived from the plants, animals, and I said that nowadays they can also be prepared from the laboratories. Right. So answer is 4. Generally, organic compounds are amorphous, complexes, covalent, and electrovalent. Covalent compounds. The vital force theory was proposed by Berzelius. Yesterday we discussed. The first carbon compound prepared from its elements, that is acetic acid. First carbon compound artificially prepared is what? Urea. Okay, but from element they are asking, so you can say that acetic acid. Main source of the most of organic compounds are coal and petroleum. The first organic compound was synthesized in the laboratory by Wöhler. The tetrahedral structure of carbon was proposed by Van 't Hoff. The first organic compound synthesized in the laboratory from inorganic compound is urea. That's formula is what? NH2CO, NH2, second option. When the mixture of potassium cyanide and ammonium chloride is heated, it gives urea. Yesterday we discussed. Organic compounds are numerous. Why? Because carbon has high catenation power. Yes. Tetravalence of carbon. Yes, this is also correct. Isomerism of organic compound. This is also correct. So all of these. Okay. So this is about this one. Next, exercise 1. J means level 1. Carbon single bond length is what? Single bond. Somewhere I written single bond 1.54 angstroms. So single bond is 1.54 angstroms. Next, the compounds of carbon other than carbon monoxide, carbon dioxide, carbonates are called organic compounds other than. Okay. Carbon double bond length. So carbon double bond length is 1.34 angstroms. Next, the unique property of carbon atoms responsible for the formation of very large number of organic compounds is called catenation. Yesterday we discussed catenation means what? Self-linkage among the identical atoms. In addition to carbon, the following atoms can be present in organic compounds, which platinum, radium, nitrogen, no, silver, thorium, no, chlorine, no, sulfur, nitrogen, phosphorus, chlorine. The fourth option is right answer. Next, the scientist who was responsible for the rejection of vital theory is Wöhler, because he prepared the first artificial, means first the laboratory's organic compound artificially. The bond angle in acetylene. Acetylene means what? Triple bond. Triple bond is what? 1.2 angstroms, 1.20. Sorry. Triple bond is, bond angle they are asking. The bond angle is 180 degrees because it's linear. Bond angle is 180 degrees because it is a linear shape. Alright. The formula of magnesite. Only one is there, C with magnesium, that is 4 MgC with magnesium carbonate. The formula of limestone, calcium carbonate. The hybridization in C2H2, this only, the hybridization in C2H2 is a sp hybridization. So, first option. Okay. So, students, remaining questions you need to practice. So, with this we completed the first synopsis. Okay. So, it's a very, very important chapter, organic chemistry. Follow regularly, don't miss any topic, and after completing, prepare, practice. Okay. Keep on practicing, so then only you will become perfect. So, I said, so there will be little differences will be there. See, like ethane, ethene, ethyne, so like this. Okay. So many compounds are there, and this all by practice only we will get. So, in the next class, we are going to discuss about the hydrocarbons and nomenclature and everything. So, till that, bye, take care.